Today we will be solving Leetcode problem 2816, double a number represented as a linked list. So what this question says, you are given the head of a non-empty linked list representing a non-negative integer without leading zeros. Okay, and you have to return the head of the linked list after doubling it. So what it says you are giving you are given a linked list which is non-empty and which consists of non-negative integers. Okay, let's say 189. So after given this linked list, you have to return a linked list which is a multiplication of this string with 2, of this list with 2. What it means to say, let's say it's 189. So 189 multiplied by 2 is 378. So you should be returning a linked list which contains 3 here, 7 here, and 8 here. So you have to like return the same linked list, same or maybe different linked list with multiplying it by 2. Okay. So let's see the example 189, 189. This is the linked list. This is the number given in the form of linked list, and the number is 189. Okay. So you have to multiply it by 2. So here, if 9 is multiplied by 2, it's come out to be 18. 1 is carry forwarded. 2 is multiplied by 8 is 16. 7 and 1 is carry forwarded. 1 multiplied by 2 is 2 plus 1, 3. So the output linked list will be 3, 7, and 8. Okay, 3, 7, and 8. But when we have like some different numbers, let's say 999, what will happen in that case? Okay, in that case, it's simple 9, 9, 9. As you know, the number while multiplying can also increase. The length of the number can also increase. Let's say currently the length of the number is 3. Okay, like it contains 3 digits, 1, 2, 3. But if you multiply triple line by 2, it becomes something which is not of, what do you say, a 3 digit number. Here it becomes 9 to the 18, 1 carry, 18, 1, 19, 1 carry, 18, 1, 19, 1 carry, 1998. Correct. So my output this time contains one extra link to this linked list. And what's that link? That link is this one here. Okay, this is the new, what do you say, a new linked list. So how can we solve this question? The basics of solving a multiplication problem is that you need to start it from left hand side. Like you cannot start multiplying from from this side. Correct. You have to always start it from this hand side. Otherwise, the result will be different. It will not be the correct result. But as you can see, in a linked list, we cannot traverse back. Okay. So let's say if I start multiplying by 2 here and then I want to go back there, I can't go because my link is only pointing towards this direction, only this direction. I cannot move in this direction. Okay, you're understanding that. So we need to find something by which we can traverse back. Either the first very basic solution that you can think of is, let's say, first traverse through a linked list, store it in a vector. Okay, let's say my number is 138. Simply traverse it, store it in a vector 138. Okay, then multiply it and create a new vector. Let's say in the same vector, I can just iterate from right hand side to left hand side using a for loop, and I just multiply it. Okay. At the end, I'll get my result. Let's say XYZ. Then I can create a linked list by these values XYZ. Correct. And then I can return that linked list. That will be the brute force solution. Okay. So that will require order of n space. Okay. And for that, I will be needed to create a vector. Okay, and it also depends whether I am putting these new values in my previous linked list or I'm creating a totally new linked list. In that case, it will become 2n if I'm creating a totally new linked list. Okay, but apart from this, there can also be a solution. In that solution, also, we are going to be using obviously n space, but that won't be you can say a data structure memory, that will be a stack memory. If we try to solve this problem with recursion, okay, Like I think you might have solved problem of trees where you have seen post order or pre order. Okay, so what do you do in post order or pre order or middle order? Let's say it's also a tree, as you can see. It's like we can say it just doesn't have its left, just right, right, and right. Correct. So let's say it's one, two, three. What's post order? Let's say first C was pre-order. Let's say I'm printing this linked list using pre-order. In that case, I will come to this linked list, this link. It's index 0, 1, 2. I'm indexing the linked list. Okay. So when I come to my node number 0, I'll print 1. Then I'll go to next node using recursion. Then I'll print that node. Then I'll go to next node. Correct. And just keep on printing that way. This is pre-order. But what happens in post order? In post order, I will not print this first. I will first go to my next node and then I'll print it. In my code, let's say I have a code, okay, of printing sub node. Okay, in this node, first I will print code for next. Okay, then I will print my current node. Correct. This becomes post order. Okay, like obviously you also know the basic concept which is stack. Like what's happening here. First of all, let's say by recursion, I am coming to this node, so a stack is created for node one. Then from one, I am coming to this node. Second, a stack is created for node two. Then I come to node three, and my stack is created for three. Then I go to next, and it's null, so no stack is created. Base condition is hit, and it vanishes. Then it comes back, and here the function tell it to print its number, so it print three. Then it pop out. Then it comes to its previous stack, which is two. Then the function is saying it to print the number two. Then it pop. Then it comes to one, it prints, and then it pop. And this stack, the recursion stack is over. So that's how recursion works. I think you have already studied a lot about recursion. So let's try to solve this question with recursion. So how we are going to do this? Okay. So first of all, while multiplying, there is also a factor of carry. You need to understand like we carry is a very important part of multiplication, definitely, right? So let's take the example of triple nine only. Nine, nine, nine. So what do I have to do? Before multiplying this, I will multiply the rest of the string by 2, and I will also take the carry out of it, like how much carry is left. Okay, so let me do the dry run of the code, like what we are going to do. Let's say first of all, like I'll come to this index, let me write the index 1 0 1 2. I come to 0. Then what I will do, I will not evaluate this, I will evaluate the rest of the linked list. Okay, so I will go for further solve head next. Okay. And after solving this linked list will be multiplied by 2 and this will return me a carry. Okay. So now I will multiply my current number by 2 and will also add the carry. Its head. So this time I will multiply. Okay. Let's say this is y. Y multiply by 2 and I will add c in it. Correct. This way my problem will be solved. Obviously I have to just mod it by 10 and I have to send the carry by dividing it by 10. Correct. That's something that we have to do. That's a very basic mathematics. Okay, so what's happening here? First I will come to 0, then I will go for solving next, then I will come to at 1, I will go at solving next, at 2 I will go at solving next. So what will be my next like what do you say, the edge condition, the break condition, that will be when I find null I have to return 0, my carry as 0. Okay, so here I will get my carry as 0. Here the carry is 0, that comes from null. So what will happen, I will just multiply the value here by 2 plus 0, so it becomes 18. Okay, and next time I will forward 18 divided by 10. Correct. 18 divided by 10 is 1. So I will send 1 as carry from here to here. Correct. Using like by the recursion, definitely. Okay. So 1 is carry forwarded and I will just mod this value by 10 to store it here. So it will be 8. Okay. It will become 8, just 8. So here, same thing will happen. I will multiply it by 2 plus 1. Here carry is 1, so it becomes 19. Okay. And from 19, 1 will be carry forwarded. Okay. And it's only become 9. So 1. And then here also 18, 1, 19. That will happen. Okay. So I think you have understood the basic concept, like how we are going to do. We are going to use the recursion. First of all, we are going to solve the rest of the linked list. Then we will solve for the current index of the linked list. Okay, let's go through the code and we will understand further. Here, what we are doing, we are returning the carry which is required by us from the recursion. I think it will be visible. So this is the main. This is the like the main runner function. Double it. So here, first of all, we will double the whole string, the whole linked list. Okay. So let's go to the function doubly. Here, if my head is null, I am returning 0, as I told you, the H condition, the break condition. Okay. Otherwise, what I'm doing, I am changing the value of head by multiplying by 2 and adding C, the carry, which has come by solving the rest of the linked list. Correct. I first have solved this, then I have got some carry here, right? Which is 1 in this case. Okay. So that's what I'm doing, solving the rest. Okay. And then I'm adding it to my current value. Then I'm creating the new carry forward that I have to send further. What will be that? That will be the current value divided by 10. And what should be the current value? As it cannot be 19, you cannot have a single integer in a number greater than 9, correct? So that will be modulus by 10, and the rest will is sent in form of C, in form of carry forward. So at the end, when we are multiplying 999, we got uh, 1992 definitely. Okay, so at the end I only had three linked lists. How do I create this new one? So what will happen at the end of the code, when it comes like all the three 999 are solved, then one carry forward will be left. Okay, like here some carry will be left, will not be 0. In that case, we'll create another node with this carry forward value. Okay, then we will add it in front of our previous linked list, in front of it. As you can see, I've created a node, and in its next we have inserted the head. So this way I have added this new node in front of my previous linked list. Okay, then I will change the position of head to this new position of head, and then I'll return the head. That way our question is solved. We can just run it. That's correct. Yeah. Okay. Good. Thanks.